Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Today we have this is another novelty from Billy Sarstead, and it is a watch. Yeah, no big novelty there. However, the problem with this watch is I think it was the batteries weren't lasting very long, and it's obviously an LED watch, old school. I think the set button wasn't working, and he said it killed a set of batteries in two weeks without use. So I'm kind of a little bit hesitant now. We're getting into the realms of, you know, slightly smaller electronics, and I'm kind of scared to break these. But I kind of see it's not. It's had a few. It's been through a little bit of the wars, so it's not like pristine. And I kind of think I've seen a few similar to it in the car boot sale, so I'm hoping it's not so rare. So there's the battery. Oh, crikey. It's all just jumped out. It's all jumped out at me. So there are the batteries. I'm going to put those aside and we're going to have a quick look inside the case. At the moment, the buttons, again, be a bit ginger because they should be spring loaded and they should retract, but if they don't, they might fall out and fire across the room, and then you're going to be stuffed unless you want to turn a new button. But yeah, that's the plunger for the mode button. You can see it in there moving in and out. That's good. And this is the plunger for the set button. Also pretty good, it's retracting and things, so that's fine. So I'm going to say mechanically it looks okay. Now look at this thing, this is crazy. Now I haven't done a video on it because I've ruined it basically. Billy sent me a Sinclair micro quartz clock and I absolutely totally trashed it. And I might have to get my microscope out one day to show you why, but if you look, I'm going to ever so carefully as I rotate this at different angles, you might see what look like fine fibres. And those fine fibres are actually the wires that go from the PCB to these LCD segments. And on the micro quartz, I just totaled them. I just absolutely shafted them. So you have to be careful with these things. You can sort of really destroy them. However, I'm also curious to see if this is a good source of a screen to replace a micro quartz. No, let's not think about that right now. Don't do a transplant. But I'm just gingerly now taking off this screen, and I'm hoping. Oh, yeah. You can see it's actually stuck to that, and there we go. Whew. So I'm just going to put this down. That's got a bit of foiliness on it. I don't want to mess with that, so we'll put that aside. There we go. So that's the screen, and yes, it's wired up pretty much exactly like the Sinclair. So again, I'm going to try hold it to the camera, see if it can focus. There we go. It can just get you a little bit closer, a little bit bigger. Now you can see here under this sort of layer of resin, these are all the lines, the power lines basically for each of the segments. So if you count them here, and there's probably a few under here that's hidden, there's your sort of 7 segments basically. And the chip select, so you see these ones here are like the chip select. So what's going on, the chip itself is turning on some of these signals which represent a number and a digit, and then it'll power up a single digit at a time, and then it'll run through them very quickly, and that's how it does it. And you can see these are the tiny wires just about going from there to there, there to there, there to there. So that's what I damaged on the micro quartz, all those wires, and they're sort of fractions of a millimeter in diameter. You can get a machine to repair them basically. They're often gold and materials like that, but the machine itself costs sort of $6,000, and that's second hand, and it's basically a massive microscope with a little like robot arm that's spooling these out, and it'll just solder them, ultrasonically solder them. And it's how you actually wire up a chip, an IC in a big processor, for example, to the PCB around it. It's done like that. So inside your PC chip, you'll have a main chunk of it, and then loads of those as well. I think they still use them. So let's not worry about that today, though, because I don't know if that's any reason that the Billy's seeing his problems, because we can't do anything about it anyway. And I'm just going to just gently poke it through from the back, because I quite like this PCB just to sort of come off. It's amazing, really. This technology would have been quite something though back in the day. Quite something now, really, if you were going to try to make this. Just gently pushing this. I don't know what's bonding it basically. It's got a crystal. It's got a big old crystal in there, and the crystal appears to be possibly is on the other side of this sticker, and it's basically stuck to it. So I'm just trying to lift the crystal by the can itself, so I'm not lifting it by its legs. Don't break that. There we go. See, it's lifted up there ever so slightly. Oh, what's it taking with it? What's it taking with it? No, it's just some glue, just some something. There we go. Done. And look, the crystal itself has got a sort of been set in a bit of an epoxy ring, so that's how they've glued the crystal to the case, and they've glued it in with a piece of silicone. So this is very much like the actual Sinclair type watches. It's very similar in its design, very simple. You've got your crystal, you've got here what I assume to be some sort of capacitor, really don't know, I think it's a capacitor, and it must be grounded to the case. It is. It's grounded to the case via the lid, and these buttons, when you push these in, are basically shorting them to the case. So I guess one danger of these is that they could touch the case, so you don't probably want them in a lot of watches. You'll have these permanently touching the contacts, and then when you push them they sort of spring and touch something else. But on this, I think it's they actually touch the case, so if these are sprung out too much, you'll get a short, so you'll be constantly as if you're holding mode button down. So that could be why Billy saw that the batteries were running down. So what I'm going to do here, I'm just going to put here a little it went all over me, bloody nozzle. So it's gone all over me at chest height, which is amazing. This is just basically hand cleaner. I'm going to take this small brush, and this is the alcoholic hand cleaner. That's all it is, something simple, like you might find in the loo. I'm going to be very gentle, knowing how easy it is to damage these. But you can see just a bit of gentleness there, and it's starting to clean off, take off that green. I advise you to get this stuff, it's really good. Just get the unscented plain hand cleaner. I don't know how it works, I don't know how the alcohol stays in a gel form, but it's brilliant, and it just does a really good job of that. Look at that, nice and clean. And I'm going to do the same to these. Oh, look at that, they're really thin, those contacts. They're okay though, I mean they're still, the greens just come off them instantly, so they're not that bad. And that's it, that's the only thing on there. That is the only thing on this board that I could see could be worth cleaning up. And I'm just going to, let's have a look at the under the light here. So it's sort of corroded, but it's just soldered in. I think that's fine. I think that's actually okay. So I think we're just going to reassemble it all now. There's nothing much more we can do. So the issue with this is probably just mechanical in terms of those spring contacts, and they're very, very fine. Scarily fine actually. I'm going to lead with those and get them in the right place, because they're going to break, and then I'll be stuffed, and I'll have to try to make something. Don't quite fancy doing that. So we're going to try to put the crystal back into its silicone gasket the same way it came out, which is not going to want to do basically. Or alternatively, I could try removing it and putting it around the crystal first. Let's see how we fare if that doesn't work out for us. Christ, look at that! I've already bent that thing. That was it without even trying. Just shows you really, it's super thin, super flimsy, and actually I can see it's almost corroded right the way through. Ugh. Now there's a big chance this bastard is going to break now. Please don't. No, it broke. Okay. Let's just get this in and then worry about it. What a pain in the bum. Right, so there's our bulging thing there. This is where it all goes wrong, you see. So that's our glue for our crystal, and we just got to decide if it needs that glue or not. I don't know, but there you go. It's just to stop it vibrating. Let's pop it all back. I'm going to zoom out a bit so I've got a bit more room here. A bit more leeway. Go. Get that in. Right, so now I've got, oh joy of joys, the need to try to recreate that contact. And just so you know, actually this isn't resin on here, it's actually the silicone, so you could even bloody damage that screen if you're not careful. Lots of things to go wrong on these watches. Now, the fun part. Trying to solder this on or do something sensible. Just got to wait for the soldering iron to heat up. I don't know. Some things, eh? Some things. I'm just getting a little bit of solder paste. I think I'm going to try on this. There we go. Get a tiny bit of solder paste. And I'm going to have to do, always tricky, left-handed soldering. Billy, this is where it might die. I do apologise in advance if it dies. Oh, no. Just going to put that case there next to that. So I've got something to push against. Need a little tiny bit more force. You've got something soldered on there. It's at a bit of a jaunty angle. I'm not too happy about that, but I'm going to see if I can adjust it. Then it's probably strong enough. I think it might be just a bit too hard. Ah, he snapped it off. Not a problem. Now what I want to do first though is I'm just going to try to clean this up, because that's causing me a bit of grief. It's taking a lot of heat, you know. You know I don't run my iron particularly cool. Let's go there. Go again, shall we? Let's have another go. This is so fine that even my tweezers are having trouble keeping hold of it. That's how fine that is. I'm going to put the watch again there. Can't see it though, the watch is just there to push against. And I'm going to try to maybe bend this tang ever so slightly in, and then I'm going to grab it, the whole thing. See if I can get it in like that. No. Bloody thing. I'm trying to work out how thick this must be at just a few microns. Another hand. I could do with another hand. Let's have another go. Best of luck. There we go. It's in. Okay, seems alright. I'm just going to keep like putting parts together. Let's just ignore it. Keep going. Seems alright. See if the lid goes on. Yeah. So it's in. It's at a bit of an angle when the camera sorts itself out, but I kind of think it's going to be, to be honest, it's going to be the best we can do, and I'm going to roll with that. Otherwise we're going to break it just by trying to keep fixing it. We'll keep fixing it till it's broken, well and truly broken. Good, so now we're at the point now where you can put some batteries in, and the batteries that came out, where did they go? Those are those ones, GPA 76s, and I don't know what the modern number is, but Billy sent me these. In fact, I did have a few open, but as with most things, of course, the few that I had open have disappeared, so I'm just going to have to keep opening more. So this is why we use up a lot of batteries, I think, because we end up with multiple sets of batteries lying around, and I'm going to find those in a moment, I'm sure. Right, so positive down that end. That one already, that battery looked really crusty already going in. And this thing has an alignment mark on the case, and there's an alignment mark on here because you need it to sort of align because of that battery door, battery contact. Let's get that on. Let's get it on. Yeah. So batteries in. Alarmingly, nothing yet on the screen. I'd quite like to see something on the screen, but no dice. No dice. Okay. More trouble in paradise. Gonna take these cells out and just test them. I think that would be a good start, looking at how crusty. Get that out of there. That is. But yeah, they already look bulgy and crusty. And look, both at this straight out of the pack, and they both even look different. Each one is differently marked. That's really weird. Weird. And there, that looks actually quite dead. Let's just see. That one's dead. That one's okay. So one out of the pack was rubbish, so we'll bin that. Let's try again. Thank you, sir. May I have another? Yes, those two look okay. And I'm just going to get the old batteries that were here and bin those two. Right, that was a bit worrying. Let's hope that that was just an issue with the batteries, not an issue with our device here. So pop those in. Again, aligning the alignment mark. And then throwing it. Right there. A lot of pressure required in this thing. It's really, really sandwiching those batteries in there. Just making sure that all of that is aligning. Ugh. Come on! Curse you! Looks okay, looks okay. See, my only issue is with this design, of course. You see this is a big square. I mean, if it touches the edge, it might not be putting enough pressure on it. So I'm just having a little look-see round, see if there's anything I've got that could do the job, so I can flip it over just to make sure. It's a sort of sanity check. Those are kind of connected-ish. No, not seeing anything on the screen. Comments, suggestions, advice? I'm at the point where I could probably do with something. A stiff drink. I think those are all okay. I don't have any worries about those. Assembled in Thailand for National Semiconductor. The only thing I can kind of do is maybe ever so slightly bend those out in case there's an issue there. I don't think so. Double check the batteries one last time though, because we know that the batteries were a bit packed. Let's just test them as a stack, shall we? Test them as a stack. Stay. Put some pressure on those. Bollocks. Over. They're very jiggly on a jiffy bag. There we go. There is 3 volts there though. There is 3 volts. They are putting out the required voltage. Put that in. Put that in. There's that back. Just going to try to do it all a bit manually. The problem is, you kind of need to short circuit between these two, don't you, to get the screen to do anything. Yeah, I kind of think that our soldering has failed again. Check. It has failed. Just going to try doing it in situ now. I'm starting to feel we have nothing to lose. Lose but willpower to continue. Come on. I need you to be friends with the piece above you. And once you'll be the best of friends, I assure you, if you play nicely. Okay. I've just got them there, sitting there. Just going to try to do, again, one more wafer thin bit that I'll probably regret. Right. So that is pretty much a belt and braces type approach there. That's a pretty significant join on there now. I'm not even sure I'll be able to get the lid on. it's that kind of thick. It's going to be very stiff compared to what it was, but I don't think that's going to be a big problem right now compared to not working. Let's get that in there. See me flopping around a bit here. Just going to do a continue. I think I need to touch it here. I don't know. Don't know if there's an issue with this trace. I think that's it. Billy, that's it now. I'm not going to do no more. We're going to try this, and if it works, it works. If it doesn't, I'm sorry, sir. I'm sorry indeed. I think it's going to be too risky to continue. Your journey will end here. So we've got positive that side, negative that side. Put the battery lid on. Damn it. Damn it, Janet. I love you. Sorry. That's a pile of fail, I'm afraid. And thank you so much for watching this all the way through. But yes, unfortunately, we didn't get this working, but at least we had a look under the hood. I feel quite sad now. I feel very morose. So yeah, Billy Sastard 1, please, maybe hand this over to someone else who might have a go for you, but I think she's a goner. Alas. But thanks for watching.